Today I want to go over limiting reagents. So I want to go over first what exactly this is, and then we're going to go through the how you solve these kind of problems. Then we're going to work through a couple of different examples. So what exactly is a limiting reagent? So a good example, just to help you to understand this, is if you think about these are all different bike parts. So here we have eight bicycle wheels, we have five frames, and then we have five sets of gears. So obviously each bike will require a single frame, two tires, one gear. So if we look at this, the most number of bikes we would be expected to make would be four bikes. We're limited by the number of tires. We have too many frames than we need, and we have more than enough of the gears than we need. So we would make four bikes, and we would have one frame and one set of gears left over. So we would say that the limiting reagent in this particular problem are the bicycle tires. We have an excess of one frame and excess of one gear. Okay, so we're going to look at chemistry problems, different reactions to determine which of the reactants is limiting, and then how much we have left over of the excess reagents. Because the limiting reagent is the reactant you run out of first. The excess reagent is the one you have left over. So limiting reagent determines how much product you can make. The chemical that makes the least amount of product is the limiting reagent. So how do you recognize that you have this kind of problem? So the way you recognize it is you will have two amounts of reactants. So remember, with the percent yield, we had an amount of reactant and an amount of product in the description of the problem. In this case, we're going to have amounts of two different reactants in the description of the problem. So there are going to be two methods that we're going to be using to figure out how to do these. The first method is the method at least I feel most comfortable with, and this is one where you do two stoichiometry problems for each of the reactants you're given, and you just see which one produces less of the product. So let's do a problem like that first. So I'm actually going to go out of here, and I'm going to show you a problem like that. So we're going to do a problem using the first technique. So the first thing you're going to do, no matter which technique you end up using, is to first write out your balanced equation. So we have copper reacting with sulfur. Remember, sulfur when it's by itself is S8, and we're producing copper 1 sulfide. So we had to first balance our equation. So we see that we need 8 of the sulfurs in our product, and then we need 16 of the coppers in our reactants. So we recognize we have a limiting reagent because we have 10.6 grams of copper, so we have grams of one of our reactants, and we have grams of our second reactant. So we're going to take each of these reactants to the product, and since we're being asked for grams of our product, how many grams? I'm going to solve for grams of copper 1 sulfide for each of our different reactants. So we have 10.6 grams of copper and 3.83 grams of sulfur. So we know that the molar mass of copper is 63.55. And then we need to take this to our moles of copper 1 sulfide. So we need to do a mole ratio. So we have 16 moles of Cu, 8 moles of Cu2S. Notice here the grams of copper cancel out, moles of copper cancel out, and then we're left with moles of copper 1 sulfide. So we're going to do 1 mole of Cu2S, and the molar mass of that would be 63.55 times 2 plus 32.07, which would give us 159.17 grams of Cu2S. So if we do this, we get So we get 13.27 grams of Cu2S. So we're going to do the same thing with our sulfur. So we have 32.07 times 8 gives us 256.56 grams of S8, 1 mole of S8 times, and then we're going to do our mole ratio. So we have 1 mole of S8, 8 moles of Cu2S, and then times, and then again, this last conversion factor is going to look identical. So 1 mole of Cu2S, 159.17 grams of Cu2S. Notice here the grams of S8 cancel out, moles of S8 cancel out, moles of Cu2S cancel out, and then we're left with grams of Cu2S. So let's multiply that out. So we have 3.83 times 8 times 159.17 divided by 256.56 grams. And we get 19.01 grams of Cu2S. So what I want you to notice here is that our limiting reagent in this problem is actually the copper. So limiting reagent will be copper, and that only produces 13.27 grams of copper 2 sulfide. I'm not sure why it's doing that. So our limiting reagent will be copper. And sometimes students might look at this initially and say, oh, sulfur has to be limiting because there's actually less of it. But this is deceptive. In this case, copper is limiting even though we have more of it. So the amount we can produce will only be 13.27, and then limiting is copper. Okay, so I want to go over method 2 now. So this one is sometimes students like this one better, because there are some situations where this could end up being less work for you. So, like I said, you have both techniques. You can decide which one makes the most sense to you. So with method 2, you're first going to determine which reactant is limiting before you figure out how much of your product you can make. So to do this, you're going to use the amount of one reactant to calculate the necessary amount of the other reactant it needs to fully react. Once you do that, you're going to compare the calculated value of the second reactant with the actual value that the reactant to see if this reagent or reactant is excess or limiting. If the amount you calculate is greater than the given amount, the second reactant is limiting. If the amount you calculated is less than the given amount, the second reactant is in excess. So let's do a problem like this using this technique. So let's look at this problem. So we have 10.3 grams of aluminum, and it's reacting with 51.7 grams of copper 2 sulfate. So let's set up our reaction first. So we have aluminum plus copper 2 sulfate. And remember, this is a single replacement reaction where aluminum is kicking out copper. So we are going to end up with copper by itself and aluminum sulfate. And we have to use our charges and write this as our other products. So now we're going to have to balance our equation. And we start with the sulfates. There's 3 sulfates here, so we're going to put a 3 here. This gives us a 3 here, and then a 2 here. So that's our balanced equation. And then we write down what we have. So again, you have 2 different grams of your different reactants. So we know this is a limiting reagent problem. So in this case, we're going to convert from one reactant to the other, and then we're going to compare our amounts. So I'm just going to choose aluminum because that's first. So I'm going to start with the 10.3 grams of aluminum, and I'm going to do a mass-to-mass conversion since we're comparing it to grams to take it to copper 2 sulfate. So I'm going to do a mass-to-mass conversion just like we've been doing, and that's going to be 26.98 grams of aluminum, 1 mole of aluminum. Notice here the grams cancel out, aluminum cancels out. And then we're going to go from moles of aluminum to moles of copper 2 sulfate. So we're doing a mole ratio. So 2 moles of aluminum, 3 moles of copper 2 sulfate. And then we have aluminum cancels out, and moles cancel out. And then we're going to go to moles of copper 2 sulfate to grams of copper 2 sulfate. And we'll use our periodic table to calculate the molar mass. So we have 63.55 plus 32.07 plus 4 times 16. So it gives us 159.62 grams of copper 2 sulfate. You notice here moles and copper 2 sulfate cancel out. So let's calculate how much we have. Okay, so when we calculate that out, we get 91.41 grams of copper 2 sulfate are needed to react with 10.3 grams of aluminum. So if we look at this is greater than the amount. So 91.41 grams is greater than 51.7 grams. And if we go back to this, if the amount we calculate is greater than the given amount, the second reactant is limiting. So this tells us that since this is greater, it tells us that copper 2 sulfate, so that means therefore, that's the symbol I always use for therefore, copper 2 sulfate is limiting. Okay, so once we know that copper 2 sulfate is limiting, now we can take copper 2 sulfate to one of the products to figure out how much of that product would be produced. So if it asks us how much, so in this case it's asking us how much copper would be produced, we're going to now take this to copper. So I'm going to make a new slide. Okay, so now we're going to figure out how much of this copper would be produced. So now that we know that copper 2 sulfate is limiting, we're going to now take the amount of copper 2 sulfate we're given in the problem and take that to the product, in this case to copper. So let's do that on the next slide. Okay, so let me just make this blank. Okay, so the problem gives us 51.7 grams of copper 2 sulfate. So let me write that in here. So 51.7 grams of copper 2 sulfate. And we know that we have a molar mass of 159.62. 159.62 grams of copper 2 sulfate and 1 mole of copper 2 sulfate. Okay, so now we're going to take that using our coefficients. We're going to do mole ratio of copper 2 sulfate to copper. Each of those have coefficients of 3. So we have 3 moles of copper 2 sulfate and 3 moles of copper. And now we're going to take that to grams of copper since we're asked to find out how many grams of copper we produce. So 1 mole of copper, and then our molar mass from our periodic table, which is 63.55 grams of copper. Okay, make sure things cancel out. And then we calculate this out. So we have 51.7 times 63.55. Remember, 3 divided by 3 is equal to 1. So this tells us that we're going to produce 20.6 grams of copper. And I did 3 sig figs since 51.7 has 3 sig figs. So our limiting, let's just label this. Well, actually, it's labeled here. Our limiting is copper 2 sulfate, and we're producing 20.6 grams of copper from that. Okay, so that's how to do it with technique 2. So just remember, important, both of these techniques will work. You will have to decide which method makes the most sense to you and use that one.